welcome to this revision video. What we're going to be looking at today is the triple chemistry only required practical based around identifying different ions. So we're going to identify the positive ions, identify some negative ions, and then use the information from that to identify an unknown sample. To start off with, I'm going to be looking at identifying different positive ions, and one of the ways that I can do that is using a flame test. So this is the first setup that I've got in front of me. I've got a Bunsen burner, I've got a wire, I don't know if you can see that on the camera, but it's just a small loop of wire. I've got my little samples in these containers, so it is the salts of different metals, and the metals I'm going to look at are calcium, lithium, sodium, potassium and copper. And then all I've got is a beaker with a small amount of hydrochloric acid in, okay, because I need to use this to clean the wire in between looking at my different samples, just so that we don't get contamination and the colours are much easier to see. Now, flame testing works because each metal has a characteristic colour when it is heated in a flame, so it's a really quick and easy way of us being able to identify which positive ion, particularly the metals, we have in our substance. So before we start actually heating these different metal salts that I've got, I need to switch my Bunsen burner to the roaring flame by opening the air hole and allowing more oxygen into the flame, allowing more complete combustion and giving me a hotter flame, and you can see now the roaring blue flame that I've got. So I'm going to start off, I'm going to dip my wire into the acid just so that the salts will actually stick to it. And I'm going to start off, my first one that I'm going to do is calcium, so I'm going to make sure I've got plenty on my wire so that we get a really good colour, and I'm going to hold it into the hottest part of the flame, which is this smaller inner cone, so you can see the brighter blue a little bit closer to the chimney of the Bunsen burner. And you can see with calcium that we get this bright orangey red colour. Okay, so a little bit's actually dropped onto the Bunsen burner, so I'm going to have to make sure I remove that before we carry on. So this characteristic orangey red, so that tells me that we have got calcium present. So I'm just going to leave that to burn for a second to burn away that little bit of calcium before we move on. So I'm going to look at lithium next. Now, calcium and lithium can be quite hard to tell apart. So again, we've got a red flame. Lithium, we typically say, has a crimson flame. Let's try this one again and see if we can see a little bit of a difference. So it's a slightly darker red. It should be a crimson flame, so we call lithium a crimson flame. Calcium is orange-red, but lithium should be a crimson flame. So I'm just going to clean that off again. So next we're going to take a look at sodium. Sodium is a very characteristic yellow flame. So old street lights, if you look at them out at night, they are this kind of orangey colour, the much older ones, and that's because they are sodium lights. They have sodium filament in there, which is why they burn, well, when they're on, they're a much more yellow colour than our modern white lights. So sodium is a characteristic yellow colour. So the next one I'm going to show you is potassium. Now, potassium can be a very, very hard colour to detect. If I get it right down at the bottom, you may be able to see, it can be quite challenging. It is a lilac flame. Now, it's such a pale colour that it is quite often masked by the other colours. So I'll try again. Sometimes if you look right down at the bottom, you can see that very pale lilac. There we go. This one's coming through a little bit clearer. So it is a lilac flame. But a common exam question can be, why is it hard to detect the colour of potassium? Or if I had a sample that contained both potassium and, for example, copper, why would I not be able to identify the potassium in this way? And it's because it's such a pale colour, it gets masked by the others and it's not very easy to see. And then the final one, copper, which is my favourite, gives us a very good colour each time. So it is this blue or green colour for copper. Very characteristic. Very easily masks any other colour that is going to be in your sample. So that characteristic, there you go, you can see it really well there, that green for copper. Now we're going to look at another method of identifying some positive ions, and this time we've got them in solution. So I have solutions with magnesium 2+, calcium 2+, aluminium 3+, iron 2+, iron 3+, and copper 2+ ions. And what I'm going to be doing is adding some sodium hydroxide solution to each of them. What that's going to do is produce a precipitate, which is purely an insoluble solid in a liquid, and they're all going to be different colours, and that is what I'm going to use to tell me what the different ions are. So I'm going to start off by just adding a small amount of sodium hydroxide to each of these, just a couple of centimetres cubed. And then what I'm going to do is I'm going to add the sodium hydroxide in excess, because that can also help us to distinguish some of these ions, and you're going to see why in a second. So just start off by adding a small volume to each of them. You should be able to see the colours beginning to appear. So our magnesium, calcium and aluminium ions are currently giving us a white precipitate. Our iron 2+ is giving us a green precipitate. I'll zoom in on these in a second. Iron 3+. It's not really giving us a precipitate yet. Let's see if I can add some more. There we go, that's a bit more obvious. So we've got this kind of red-brown precipitate forming. And then copper 2+, we've got a clear blue precipitate that has formed. So we're going to focus now on the aluminium, the calcium and the magnesium ions, because as you can see, they've all formed a white precipitate. So we would not really be able to determine which is which if we had just these three results at the minute. So now I'm going to add my sodium hydroxide in excess and see what happens to the precipitate. So magnesium, going to add more, still cloudy, still got a precipitate in there. Calcium, let's add a bit more, still cloudy, still a precipitate. Let's have a look at aluminium. And you can see if I add a little bit more, that precipitate has now dissolved, okay? So you can identify the aluminium ion from calcium and magnesium because the aluminium hydroxide precipitate, which is what was formed, which is what the precipitate is, will dissolve when you add an excess of sodium hydroxide. So all of these precipitates that have formed are hydroxides of the different ions. So we've formed magnesium hydroxide, calcium hydroxide, aluminium hydroxide, iron 2 hydroxide, iron 3 hydroxide, and copper hydroxide. And all of these are insoluble. Okay, so that's why a precipitate forms, and we can see these lovely different coloured solids. So just going to add a little bit more to these to make them a little bit more obvious. Next, I'm going to be looking at the tests for the different negative ions we can analyse in the lab very easily, and I'm going to be showing the positive results that you will get if there is a carbonate present, the positive results for the different halides, and also the positive results for if the sulphate ion is present. So this is the test to detect the carbonate ions. And what I've got here is I'm going to be using a little bit of potassium carbonate. I've got some lime water and a delivery tube, and I've got some hydrochloric acid. And what I'm going to do is I'm going to add the hydrochloric acid to the potassium carbonate, and what's going to happen there is it's going to produce carbon dioxide as one of the products. Now, as we know, when carbon dioxide is bubbled through lime water, it causes the lime water to turn cloudy. So this is why this is a really good test to show if we've got carbonates, because they will always produce carbon dioxide and they will always make lime water turn cloudy when the gas is bubbled through. So now I'm going to add the hydrochloric acid to my potassium carbonate and then very quickly try and get the delivery tube in so that we can get all of that carbon dioxide into our lime water. Go. Add a little bit more acid. Sometimes it takes a little bit more to get it going at these concentrations. There we go. So it's clearly fizzing now. Hopefully we should be able to see that it is bubbling quite nicely into the lime water, and over time we should see that lime water turning cloudy. So this is the test for sulphate ions, and what I've got is some sodium sulphate, so that's what's going to give us our positive result for this test, and I've got some barium chloride. And all I'm going to do is add the barium chloride to the sodium sulphate. If there are sulphate ions present, which there will be in this one, you will get a white precipitate of barium sulphate forming. So that is from the barium chloride reacting with the sulphate ions that are present in the sodium sulphate. So now I'm going to add some of the barium chloride to our sodium sulphate, and you can see there a very obvious white precipitate has formed because a precipitate of barium sulphate has formed from the barium chloride reacting with the sulphate ions in the sodium sulphate. Now we're going to look at the test to identify the presence of the different halide ions. So we're going to be looking at the result for chloride ions, bromide ions, and iodide ions. And the way that this works, I've got my solutions with the ions present. I'm first of all going to add some dilute nitric acid, and that will remove any other ions that might be in there and interfere with the results. And then what we're going to do is add some silver nitrate, and we will look at the different coloured precipitates that will form for the different halides present. So the first thing I'm doing is adding a small amount of dilute nitric acid to all three samples to get rid of any other ions that may be in there and that could interfere with our results. There we go. And then I'm going to add the silver nitrate, and we're going to take a look at the different coloured precipitates that form. So going into the chloride solution, we have a clearly very white precipitate. For bromide, so it still looks quite white. I will zoom in on this in a second, but we say it's a cream precipitate. You can see it's a little bit more yellow than the chloride ions. And then our iodide ions. So this is much more yellow, so this is a yellow precipitate for the iodide ions. And that is how you distinguish whether you have a halide ion and which one you have present by looking at the different colour of the precipitate. Chloride ions produce a white precipitate, bromide ions produce a cream precipitate, and iodide ions produce a yellow precipitate. Now that we've looked at the positive results for all of our different tests for identifying positive ions and negative ions, we're going to use that knowledge to identify an unknown solution. Now you need to be able to do this, and you are also expected in your exam to be able to identify an unknown solution using the results of the tests that I have just described. So I'm going to go through one by one, beginning with the flame test, to try and identify the solution that I have in this bottle. Okay, so we're going to start off with our flame test. So I have soaked this splint in our unknown solution rather than using the wire, just because it's quite hard to get any to stay on the wire with it being a solution, and we're going to have a look at the colour. So it's quite a yellow flame that we're getting, a very obvious yellow. It's not just from the burning of the splint, that is from the solution in there. So if we've got a yellow flame, that would suggest that we have sodium ions present. So what I'm also going to do is I'm going to test with sodium hydroxide, because if it is sodium ions that are present, we're not going to get a precipitate, and then we'll continue and look at our negative ions. So now we've done the flame test, we're going to run through the other tests that we have been doing to identify our other ions. So the flame test gave us a yellow flame, which would suggest the presence of sodium ions. I'm going to add the sodium hydroxide anyway, like we did with the other positive ions. And there is no precipitate formed, so I would suggest that the ion we have present, the positive ion we have present, is sodium. So let's take a look at our negative ions then. So let's start off by doing our carbonate test. So I also have some lime water ready to go and my hydrochloric acid. So if we see any kind of bubbling or fizzing, I'm going to get the delivery tube in and we'll see if we have a gas that is carbon dioxide. So let's add some hydrochloric acid. Add a little bit more because last time it took quite a bit. Well, there's no fizzing at all, there's no gas being produced, so we don't have a carbonate because there's definitely no gas at all being produced, so there's definitely no carbon dioxide, which would tell us we had the carbonate. So it's not got a carbonate ion in there. So far we know we've got sodium, we don't know what the negative ion is. So next we're going to have a look at our sulphate ion test. So I'm going to add my barium chloride and see what happens. And there's no precipitate formed, so there are no sulphate ions in this solution. So that would suggest to me that we're going to have a halide in there, because that's the last test that we've got. We don't know which halide. So let's get this ready. I'm going to get my hydrochloric acid to remove any other ions that might interfere. I'm going to add a little bit of that in there. Sorry, it's nitric acid, it's not hydrochloric acid, it's nitric acid. And then I'm going to add my silver nitrate and we'll see if a precipitate forms. And it does, it's formed a precipitate. It has formed a white precipitate. So that tells us we have a halide present, and that halide that is present is the chloride ion. So from the results of all of those tests, my unknown sample is sodium chloride.